Good morning, chemistry students. I wanted to go over just a few questions from your ChemQuest 14 average atomic mass that in the past I've typically found students struggle with. So I'm not going to go over every question. You have a key with answers shown on it, but I want to go over a couple of them that even with the key you might still have some questions about. So the first one we're going to look at is question number 1 that says calculate the average grade for students A and B and enter the average in the table below. So it asks for the average down here just to make sure, right? This is straight up average like you've done in the past. So remember, to figure out an average, you add all the scores together and you divide by the number of scores that there were. Right, so for student A, I'm going to do 95 plus 74 plus 82 plus 92 plus 81. All of that divided by 5, okay, because there are 5 scores. And that should give you about 84.8 as the average. For student B, you're going to do 76 plus 88 plus 90 plus 81 plus 72. And then again divided by 5 because there are 5 scores. And you should get about an 81.4. Okay. Again, straight up average like you've always done average. Okay. Nothing really revolutionary there. Question number 4, though, asks about a weighted average. So question 4 says, what if the teacher decided that the first 5 would count for 40%? Oh, sorry, the test 5. So, sorry, I read that wrong. Okay, test 5 would count for 40% of their grade. And test 4 would count for 30. And each of the other tests would count for 10%. Okay, this is a weighted average. And in fact, this is how your grade is calculated in my class. So when I want to calculate a weighted average, my equation is my percent as a decimal times the score plus my percent as a decimal times the score, and I'm just going to write plus, etc., right, for however many times I have to do that. In this case, I'm going to have to do that 5 times. So for student A, okay, it's going to be 0.1, because 10%, right, to take a percentage and make it a decimal, we go move our decimal place 2 places to the left. So it's 0.1 times 95 plus 0.1 again times 74 plus 0.1 again times 82 plus, this time it's going to be 0.3 because it's 30% times 92 plus 0.4 because it's 40% times 81. When you do that, you should get about 85.1 on your calculator. Okay? When I do that for student B, I'm going to do the same thing. So their weighted average is going to be 0.1 times 76 this time plus 0.1 times 88 plus 0.1 times 90 plus 0.3 times 81 plus 0.4 times 72. When you do that, you should get about 78.5 on your calculator. And again, In my class, your grade is also a weighted average. So in my class, you can't simply add up the number of points you earned and divide it by the points possible and figure out your grade. In my class, you have to do a weighted average. So again, this is going to be important because what you're going to see is when we move to number 5, to figure out the average atomic mass for any element on the periodic table, it's a weighted average. So number 5 says, neon has 3 different isotopes. 90.51% of neon atoms have a mass of 19.992 AMUs. 0.27% of neon atoms have a mass of 20.994 AMUs. 9.22% of neon atoms have a mass of 21.991 AMUs. What is the average atomic mass of neon? So, again, my equation for this is going to look really similar to the equation I just used. It's going to be my percent as a decimal, but this time, instead of times the average, right, it's going to be times the mass plus my percent as a decimal times the mass plus, again, still that, etc., because depending upon how many there are, right? In this case, there are 3 isotopes, so I'll have to do this 3 times. So to calculate this for neon, my first percentage as a decimal is 0.9051. My first mass is 19.992 plus, now 0.27 as a decimal is actually 0.0027. So I still have to move my decimal 2 places to the left. Okay, times 20.994 plus 0.0922 times 21.991. Again, when you do that on your calculator, you should get an answer of about 20.179 AMUs. Now, why did I use 3 decimals here? Because up here, they use 3 decimal places for all of them. So just kind of be consistent with the problem with that. Use the number that they're using. So for 5, this is how on anywhere else on this ChemQuest, you would use the same equation here to calculate the average atomic mass. So taking a look at number 7, number 7 says, of all chlorine atoms, 75.771% are chlorine-35. Chlorine-35 atoms have a mass of 34.96885 AMUs. All other chlorine atoms are chlorine-37, and these have a mass of 36.96590. Calculate the average atomic mass of chlorine. So again, we're still using that same equation, that our average equals our percent as a decimal times the mass plus our percent as a decimal times the mass. And this time I only have to do it twice because there's only 2 isotopes. But notice I'm sort of missing something here, right? I don't have this other percentage. So this works on that assumption that you understand that if there are only 2 isotopes of something, they have to total 100%. So to give you an example of that, if in class, if you have a class that is 45% girls, what percentage of the class are boys? 55, right? Okay. So the idea is that the 2, because there's only males and females, let's say, in class, they have to total 100%. It's the same idea here. So to figure out this missing percentage, I'm going to do 100% and subtract my 75.771% to figure out that missing percent. Okay? Which ends up being about 24.229% when you put it in your calculator. Okay. So now I do indeed have everything that I need to do this problem because now I know this missing percentage. So my average is going to be 0.75771 times 34.96885 plus 0.24229 times 36.96590. Okay, and when you do that, you should get about 35.4527. And you might even have had, honestly, if you're kind of consistent here, right? This has 5 decimal places and 5 decimal places. You might even have gone ahead and written this 5th decimal place here. Okay. Again, I'm not real picky about that. As long as you're getting somewhere near this answer, you're doing a good job. Okay. So that kind of helps you out with number 7. The next one I want to look at is number 9 that asks you to complete the following table. So a couple things to remember here, right? The number of protons and atomic number are the same. Our mass number is our number of protons plus our number of neutrons. Okay, so using that information, and remember when we're given information in this format, the top number is our is our mass number. Oops. And the bottom one is our atomic number. So using that information for this first one, okay, we know that our atomic number is 15, and atomic number, remember, is the same as our number of protons. So this is our atomic number. Okay, so if my atomic number is 15, that means that I have 15 protons. Now, because this is a neutral atom, and I know it's neutral because I don't see a charge up here, all neutral atoms have the same number of positively charged protons as they do negatively charged electrons, so I have to have 15 electrons as well. The atomic number is 15. Okay, so the mass number, how do I get my mass number? Well, I'm going to do 31 minus 15. Okay. Oh, sorry. That's mass number is the number of protons and neutrons, which is that top number. So they already gave me that. The one I have to figure out here is my number of neutrons, which is going to be my mass number minus my atomic number, which gives me 16. So in the second one, again, my bottom number here is my atomic number. So that means I have 13 protons. That means I have, we're going to leave that blank for a second. That means my atomic number is 13. Now, electrons here, this one's a little bit different. We haven't talked about this in class yet. So it's not a big deal if this a little bit goes over your head, but this atom is not actually an atom, it's an ion. It has a charge. And plus 3 means that it has 3 more protons than it does electrons. So to get the number of electrons, because it has 3 more protons than it does electrons, I'm going to do 13 minus 3, which is 10. The mass number is 28. That's our top number up here. So now to figure out the number of neutrons, I'm going to do 28 minus 13, which gives me 15. All right, this next one. Again, they tell me my atomic number. So that is also the number of protons. So that has to be 38. To figure out my number of neutrons, it's still going to be my mass number, which is 80, subtracting my atomic number, which is 38, which is going to be 42. So this time, though, they asked me to fill in my symbol. So I have to look at my periodic table and find number 38, atomic number 38 on my periodic table, which is the element strontium. I know that this doesn't have a charge because the numbers of electrons and protons are equal to one another, so I don't have to worry about putting a charge. So I'm going to put my mass number as my superscript and my atomic number as my subscript. And so there's my symbol. For the next one, again, my mass number is 119 because that's my top number. 50 is my atomic number. This doesn't have a charge because there's nothing here, so that means that my atomic number is my number of protons. It's also my number of electrons. To figure out my number of neutrons, it's going to be my mass number minus my atomic number, which gives me 69. All right, our next one. Again, they gave me mass number, but atomic number is missing. But remember, atomic number is the same as my number of protons. So my atomic number is 84. To figure out my number of neutrons, I'm going to do my mass number, subtract my atomic number, and so that's going to give me 126. Notice here again, my protons and electrons are equal, so this is not going to have a charge. So I look up element number 84 on my periodic table, and it's polonium. No charge, so I don't have to put a charge. So my mass number is 210, and my atomic number is 84. All right, this next one. So they tell me the number of neutrons, and they tell me the number of protons. So to get this missing mass number, I'm going to add them up. So 8 plus 7 gives me 15. Excuse me. Okay. Now, atomic number is always the same as our number of protons, so our atomic number is 7. So notice with this one that my protons and electrons are not equal, which means this is going to be one of those ions that have a charge. But first, let's find what element we need. Our symbol, so to find our element symbol, we're going to look up atomic number 7 on our periodic table, which is nitrogen. Again, we can go ahead and fill in our mass number, which we said was 15, and our atomic number, which we said was 7. So now, what do we do with the fact that we have an unequal number of protons and electrons? Well, remember, protons are positively charged and electrons are negatively charged. So if I take plus 7 and minus 10, I'm left with a charge of negative 3. So my charge here is negative 3. And number 10, question number 10, is just like number 7, where they don't give you all the information you need and you need to calculate that other missing percentage. So I hope that that helps a little bit with some of the questions that you might have had. Question 11 is done just like that neon one that we did, number 5. Okay, so 11 is like 5. So I hope that helps. Have a great day. Talk to you tomorrow.